Hello, my name is Selim Reza. I'm from Bangladesh. I'm a MSc student of Electronic Engineering Department. Today I will deliver my lecture on biosensor performance parameters. Now I'm going to show my slide. Firstly, I will talk some outline of this lecture topic: range of glucose concentration, S parameters, response times of sensor, resolution and linearity, reproducibility, or it may be repeatability, RF sensor sensing techniques, invasive glucose sensing, minimally invasive glucose sensing, non-invasive sensing, and advantage of RF resonator type of RF sensing, and glucose monitoring via capacitive RF space. Actually, the glucose sensor performance parameters are different technique on depend on their performance. We have some topic on to be level of concentration of glucose. Basically this performance of this glucose sensor are um, measured from the level of glucemia of the human serum and from the D-glucose solution. Basically this glucose sensor measure or implement the maximum and minimum values of applied serum. And if we in this table we illustrate or plotted some range of sample, and the non-fasting random glucose level is 148 to 248 milligram per dl, and the second sample of the serum is 1.5 to the 2.5 ml to dl, and the human serum with a glucose of 65 to 245 ml. Basically these serums are put on the centrifusion process, and here we see the first machine is the differential centrifugal machine. In the for this machine uses for the bioseparation actually, and centrifugal tilting use the centrifugal force for separating this. And this the second paragraph is the paper for D-glucose sample and exposed to vector network analyzer as a prototype glucometer. And the last the figure 1 is take some blood sample of rail mats and put on this centrifugal machine, and it will just separate it into two part, one top of the serum and later part is the lead blood cells. Actually this the two by the centrifugals, and we determined the data from the D-glucose and also data from the serum. We compare with them and try to relate it the relative shifting of the resonance frequency, and depending on this we take a decision as it to the sensing of this glucose sensor. Basically this S parameters are used in these cases to measure the parameters. The vector network analyzer is used here. It's nothing but to measure in to help the vector analyzer. And why we the S parameters are actually when we try to any measure voltage or current of the device in a port in a high frequency, it is difficult to position the probe in the correct position, or maybe interference with each other or something with each other. That's why it is difficult to measure the connecting or physically connected the probe. So S parameters help us to relieve or mitigation these types of process. S parameters define is a term of voltage traveling waves and which are relatively easy to measure and don't record any undesirable loads to the devices under the test. Response time is also actually a time used by the sensor to produce the required estimated frequency response. It is minimum time to by taken by a sensor to response the output by sensing is inputs and samplings. And we also see that AMIS capacitor is the one of the glucose sensor based on glucose sensor which is show the excellent response time. And in this chapter or in this book we uh, just aim to our focus to improvement the response time. This we have to detect the response time for this glucose sensor for 60 seconds is the maximum and the minimum value is 14 seconds. And the third term of the parameters of sensor is to the resolution. It is the minimum concentration of a glucose by this sensor can easily uh, can sense by a sensor. If we a small value are taken, so it will make us to be device the small, and with the small concentration it will be improve the efficiency and accuracy also. And the third is that and the third point is that in the resolution we take a high detectable resolution as 0.661 megahertz per kb mg for dl to 3.4 picometer mg dl. And we take our samples as a sample serum concentration level 65 to 245 mg dl, and the glucose concentration is 65 dl. And after that we observe and show and observe that it was show the high reliability. Basically the vector node analyzer set a resolution that can detect minimum changes of frequency approximately 3 megahertz, and the resolution of proposed devices was calculated by the 2 megahertz dBl. And the another parameters we also just from the by from this glucose sensor to depend on this performance. Firstly we measure the real curve of the glucose sensor, and it will actually it's not real, it's an ideal curve, and and we compare with the measurement curve, and these are related by the correlation of the calibration by correlation coefficient. These are evaluation from these are both are evaluation from the coefficient. In the ideal cases the coefficient is also 1, and with the performance decreasing of the sensor it will less than 1 depend on the performance of sensor. Repeatability is the of a it's also a parameters to have a good glucose sensor. It's actually basis on the repeatability of making a sensor with the same condition, with the same measurement, same environment, and it will work with the same performance as the before and after the test. So in this books or in this experiment we conduct 14 times of set experiment. We take a concentration calibrated from minimum 65 dBl to the maximum concentration is a 248 dBl interval by 20 dBl, and we also set the calibration condition at the same as the VNA dot for each of the 14 times, and the same volume the glucose we take in for the for 40 times. And we also the constant that ambient temperature is 25 degree is the room temperature. And we observe to observe two things: statistical analysis. It is also related to the standard deviation and coefficient of variation each of the sample we just measure, and we found that the relative standard deviation is less than 0.5%. And another study we from this repeatability is that atomic force and microscopy analyzing is also surface of the of performance measure. And for this we want to pre-treatment and sensor load with the glucose, and post-treatment also made that. Actually today or most recently the RF technique is most popular. Basically is more the first reason is that the easy fabrication, short response time or time, moderator free detection. So that's why they are popular the most in the cases. Basically the RF sensing technique uses various types of transducer and the RTT. And the main block RF technique element is the resonator and the characterization of the surface of certain resonance frequency for removal of the glucose molecules. And basing on this, they are working on that. The design of the RF glucose are very highly sensitive and could show the reliability and low limitation of detections and mediator free. So another type of cavity also uses in the RF sensing technique, the cavity loaded micro resonator. And here we see a a pictorial view of the resustain of RF biosensor with a different element. It will start from the quartz surface uh, crystal quartz membranes and to the and with the RFID radio frequency identification. Glucose is a method, invasive glucose sensing method, non-invasive, invasive glucose sensing method, and another technique also. And the first I talk about the invasive glucose sensing technique. Actually, these types of sensing technique, the needle, one type of needle which push on the hand or blood, which directly access to the interstitial fluid or blood and make the measurement direct through the offline analysis. Basically, these types of sensing technique uses in the continuous glucose monitoring system and substantially implemented needle type of implemented glucose biosensor commonly mostly uses the commercially. These types of sensing technique uses two type of electrodes. One is the working electrode and the reference electrode. And based on the principle, measure the current by the enzyme catalyzed electrooxidation of glucose by the oxygen or and redox active couple. Here is the figure. You can see this is the needle and this is the invasive needle type glucose sensing. Basically it will be embedded in the same platform or maybe different platform also. It will depend on the mechanism. And here also we some design of RF implantable glucose sensor with embedded chip. This is a transponder chip. Actually this is a transponder chip, and this dimension of this chip is almost 4 millimeter to 8 millimeter, and thickness is 1 millimeter. And these are the coil. Now the working is this. This is working electrode, and this is the reference electrode. And when this the glucose sensor changing the concentration on the electron change, and it will produce the current. And this chief transponder actually passes and process on this current, and by this helping of this tank circuit, it produces a RF frequency. And by the inductive method, this external coil, this is so it can get cut the secondary and go through the amplifier, and signal will be amplified and data also detected and processed on this unit by this raw data. It's actually a radio sensing two types. Another signal and sense on any wireless devices to sense, and then to be sensor, it will be sensor will be sensed, and after that it will be transmitted to the external body. Another type of in glucose sensor, it is minimum. Here we see a tube type, needle tube type sensor. The reason is focusing on there, and it is a sensor patch, and this is the red also the sensor. Actually, this type of sensor techniques, the monitoring glucose via the skin are reported. It's not the skin actually observe this. With this they are working with. And these types of sensor compromise the needle type microscope and a sensing element. And these are the painless penetrating the skin barrier and access to the interstitial fluid on blood, and interrupt with the electromagnetic radiation. All the human body electromagnetic radiate. So from this electromagnetic radiation with the tissue and interaction the fluid, electromagnetic induction, the sensor can sense the surface and produce this sensitivity current voltage. Here we are current is graph. Here also we have some other also graph for durability and the productivity of this graph. And the figure of the real figure of a watch, it is the glucose twisting watch, which is invention in the before, and there is all the electrical circuitry are operated, isostasis and biosensor functionality. And another non-invasive glucose sensing, also another technique of glucose sensing is a non-invasive. Here you see here you see the non-invasive technique is nothing but to it will interact with the skin and to the sensor. It not to be any type of needle or something like that. So these are the plotted on this skin like as that. It is the one is the negative electrode and the positive electrode, negative and positive electrode with the mil input in it. It will just the difference between the ion and produce the current and voltage, and this voltage changes to be are measured by the performance of the by the sensor and the pre and post treatment. And also in this the third, it will actually the tattoo base invasive. It tattoo base. Here we also see the an aerogel into the in our hand, and it is actively working without any painless. And another type of invasive sensing technique is to be multiplex flexible strain gauge sensor based on reversible interlocking of PT cathode polymer nanofiber. And the first Siemens you have sandwiching on this, and in this technique we will just pressure, and these are the assembly of the preparation. And B is the assembly and operation of a flexible sensor and layer sandwiching between the PDMS supported at approximately 500 micrometer thickness each of. And the flexibility of this sensor very high. So here we see in this B diagram, and the C also Siemens of sim image of radius nanometer, and also the D the Siemens of the pressure, shear and tension also applied to this geometrical dimension. It appear here. And the operation of the flexible layer by the means of resistance changing, like as that produce this graph. Basically this biosensing technique has a lot of advantages, and we are using in the biosensing technique a lot of various types of resonator. So there is a lot of advantages came from this biosensing technique. The first one is the RF biosensing technique have been implemented in the design and detection of various types of disease. And the another advantage of this using a micro resonator as a transducer, it analyzes the volume and required for accurate and reliable sensing. And the resonator, this type of resonator also help to the small sample of size, and the different arrays of resonator can be implemented with a simple chip and detected different biological sample simultaneously. And it also senses the accurately and reliable sensing and immobilization of RF biosensor. We can the chemical surface can be modified, and it shows the excellent stability. Another type of glucose monitoring system is the via capacitive ER base. The first one is the diagram, the symmetric diagram of the fabrication of the glucose sensing, and the second one the 3D view. Here we see that the gallium arsenide is plotting, and here is also the Si3 silicon nitrate for this for this oxide for this layer. And also we talk of this ER bridge serum. And here also some the force ion beam pictures across and fabrication glucose sensor. Basically this type of capacitive ER based sensor are also measured in atomic force microscopy. Here is the pre-treatment, and after it will the post-treatment unload the serum. And here is this process also shown in the by the AFM. This is the frequency with the various response frequency here shows by the color, and here is the concentration changing with the capacitance. The blue one is the black one is the capacitance. With the decreasing of the capacitance, the decreasing of the capacitance concentration with the number capacity proportional. And here we also see to of capacity equation to based on the two-way relation process of aqueous glucose solution of complex permittivity expresses permittivity at a high frequency, and the static permittivity of angular frequency and relaxation constant in this medium. And we measure the transmission variation with the concentration level of the glucose, and is calculated by this using of the formula. Here we also summarizing some magnitude of the expressed complex number representation. And after that, by the discussing the phase plot equation, also here we see this is the phase plot of the equation by this, and the capacitance of the different concentration of the glucose level also calculated by this. So thank you for watching my video. I hope a good day.